Hello and welcome to lesson 1 of week 6. In this lesson, we are going to look at the different table operations in MySQL. My name is Mildred. In this lesson, we are going to use the access control database that we created in the last lesson. We are going to use this to illustrate all of the table operations. Now, in this access control database, we're going to have different tables that we want to use to illustrate these different table operations, and in the next lesson, we are going to illustrate transactions. Now we want to design this table to have the users table, the rows table, the permissions table, and also to have the user permissions table. We want the users table to store the system users. We want the rows table to store admin, editor, and viewer information. We want the permission table to store actions like read, write, and delete. And then we want the user permission table to map users to permission. Now this structure we have is like a many-to-many relationship model, and in a many-to-many relationship model, multiple rows in the first table can be related to multiple rows in like the second table. And so for us to create a table, we use the create table statement. So we're using access control, and then we write our statement like this: create table. We use the if not exist statement in the event that the table already exists. You just want it to give a warning and move on without giving an error. And then in a pair of parentheses, we want to start putting the column names and all of the constraints, the data type constraints that we want to put. So we want the first column to be called user ID. We want this user ID to be a data type integer int. We want it to auto increment, and we use auto increment when we want to insert a number, maybe 1, and automatically increments to 2, so we don't have to insert a number for that column whenever we are inserting a new data. And we want this to be the primary key. Now we want to have a username column, so let's just spell it username like this. We want this to be a variable character of length 50. We want it to be not null, and then we also want it to be unique. Okay, we looked at all of these constraints last week. So we want to have an email. We want it to be a variable character of length 100. We want it to be not null, and we also want it to be unique. Then we want to have created at, and we want this to be a timestamp. Okay? And then we want the default to be the current timestamp. So when we have the default constraint, it just gives a value when no value is inserted in it. And this should create the users table. We want to create another table, which is the rows table, where we have the different rows for these different users. So we use the concept of primary key here. We use unique constraints. We use auto increment. We use timestamp here, and you can refer back to past lessons or research to see the meaning of these constraints if your notes from previous lesson does not cover that. Let's create the rows table. So let's say create. So we'll create table if not exists, and this table will be called rows. We want to have the role ID. The role ID will be an integer. It will auto increment. We want it to be a primary key. We want to have the role name, and we want the role name to be a variable character of length 50. We want to enforce the not null constraint here, and we also want it to be unique. Now we want to ensure that for this, let's use a semicolon. So for this, we want to ensure that the role names are unique, and we want to keep the data normalized, something like that. So when you get to the last one, you don't put a comma. You want to have the permissions table, and so let's create table if not exists permissions, and we want to have, let's say we have permissions ID. Let's have permission ID, and let's say this is an int. This will auto increment, and let's say this is also the primary key. We want to have permission name. Let's say this is a variable character of length 50. This is not null and unique. Let's create one more table. What we want to add to this permissions table is the read, write, and delete permissions. And let's have another one, which is going to be the user permissions table. So we'll have create table if not exists, user permissions, and for this we'll say user ID. We want this to be int. We want this to auto increment. We want it to be let's do this a different way. Let me show you. Like this will be a junction table. So we'll do this like this. Let's just put only the data type, and then you have permission ID, and we'll make the permission ID int. And then we want to have granted at, and we'll put this to be timestamp. We will make the default default to be current timestamp. Then we want to have the primary key. So we have primary key here, and then in a pair of parentheses we can put the primary key to be user ID, and then references. So we want the primary key to be both user ID and permission ID, and then we will have a foreign key. So a foreign key is just to keep the asset property, because we are trying to link this to a parent table. So we have user ID here and permission ID, but we have a user ID in the users table, and then we have a permission ID in the permission table. We want to link these two together, right? And when we create the user permission table, we want to be referring to this ID from this parent and this permission here. So we don't want to repeat it on this table. We want to make sure that if this is deleted, it's deleted here. If this is deleted or updated, it is deleted or updated here. So we're just making reference, and so that's why we want to now, this is the foreign key, and foreign key we have here is user ID, and then what will be the references. So you put foreign key user ID, and we are referencing, now it's going to be the parents table. So we'll say references is going to be users. So user ID's parent is the users table, and the column on the users table is still called user ID. So you say user ID. So the foreign key is the user ID column here, and the reference is the users table on the user ID column. Okay, what do you want to do with this when you update or delete? So you can now say here on delete cascade. So once you write on delete cascade, what it means is that once you delete the parent table, then the child table is also deleted. All right, once you delete that row from the parent table, the child is deleted. We have another foreign key, which is the permission ID. So we'll say foreign key, and the foreign key here is permission ID, and then references is going to be permissions, permission ID, and then we'll do the same cascade. So we'll have on delete cascade, and if you want it to cascade on updates, you can also put on update cascade. Here you can do like on update cascade like this also. All right, so we just want to make it on delete. So this means that when you update this, let's say you change the user ID here, it will change on all of the child tables. So you can use on update cascade. Let's use only on delete on this. Okay, so let's say we are done with all of this. Now we are doing this without using transactions. We're just trying to create these 4 tables. Now if all is well and we run, it should create all the tables. When we refresh this, we should see all the tables here. Permission roles, user permission, users. We have the tables now. So now we use the on delete cascade to keep this consistent. The primary key will prevent duplicates when we have it here, and it enforces not null and uniqueness also. So we use that composite way here to enforce not null and uniqueness. Now there are other operations we'll do. We've created a table. How do we insert the records into this table? Sometimes when we insert, we can use transactions, especially for things where it must succeed together or fail together. So let's use access control again, and then I want to say I want to insert. The syntax for insert is insert into. So you can either say insert into, or you can add ignore here. Insert ignore into the name of the table. Now we use ignore just like if not exists. So if the record, exactly the same record, exists in the table already, you want to ignore it. So it will not cause an error, it will just give you a warning. But if it doesn't, you insert into it. So say insert ignore into users, and then on the users table we have username, and then we have email. So say username, email. So we'll not put the user ID because we made it auto increment, so it will just start from 1, 2, 3 and increments like that. So we say insert ignore into users. We have the username, email, and then we'll put the values. And for the values, we want for the username, let's say we want the username to be Alice, and then the email, let's say alice@example.com, and then we also want to insert another one. Let's put another value here, and we'll have the name Bob and the email, let's say bob@example.com. So we have 2 records here. We are inserting into the users table the columns username and email, and the values that will insert into this username and email is alice@example.com. You want to make sure that you put the values in the order in which the column names exist here, right? And then the same thing for Bob. When we run like this, we will see that we want to see if this worked. We can use the select query and say select all from users, right? And then when we run this, we'll have the table of users, Alice and Bob, and so we see user ID auto increment automatically. They created that there. So we can insert also into the rows table, and for this rows table we have the row name. Row ID will auto increment, so we can change this to rows, and we'll see that we have nothing, just row ID, row name. So we want to put in the row name column. So let's say insert ignore into rows, and the column name is row name, and the value we want to put here is, let's say, admin, editor and viewer, something like that. So the values here we have, let's say we have have admin, we have editor, and then we have viewer. So we have these three, and when we're done, we want to select all from rows. So I will run this. It's going to insert, and then we have it selecting. We want to do the same thing with the permissions table. So we'll say permissions here. So we're insert ignore into permissions, and the only thing we have for permission is permission name, and then we want to put the values. Let's say we want to have a value read, we want to have a value write, we want to have a value delete, like this. And so when I run this, we have read, write, delete, the permission ID 1 2 3. So it just gives this in delete, read, write here. So we want to insert again into user permissions. So let's say here we'll do user permissions, and here we'll say insert ignore into user permissions. Now we have user ID and permission ID. So let's say user ID and permission ID, and then we want to say we only have user ID 1 and 2 for Alice and Bob. So let's say Alice can read, so it's 1, and read is ID 1. So Alice is 1 1, right? And then we want to do the second permission. We want to say Alice can write. Alice is 1 and write is 2. And then we want to say, let's say Bob can read. Bob is ID is 2 and read is 1. Let's do that like that. So we have these values we want to insert here. So we're using just the permission ID and the user ID. And when I run this, we will see the user ID and the permission ID. So this one will map users to permission, and it will enforce integrity via the foreign keys that we have. Now, if we want to view users permission, we can select using the join operation to select the user name, and we'll select the permission name from users, and then we'll join based on the user ID and the permission ID if you want to use a join to see the name of the permissions that they have. Now we have another table operation for update. When you want to update, let's say for instance we want to change Alice's email, the syntax for updating is, let me just use this as select all from users. So the syntax for updating is writing update, and then you put table name. Table name we want to update is users, so say update users, then set. So update table name, set the name of the column. So we want to set email is equal to, and then want to put the email that we are setting. So let's say email is equal to, let's say we want to make this email alicenew@example.com. Now you must use a where clause to know exactly which row of information you are updating. If not, you update the entire table. Okay, so I want to say update users set, so update table name set column name equals to the value, then you use for the condition where the username. So you want to use a condition or a column that is unique to that user. So where the username is equal to, so let's assume the username is unique and the username is Alice, like this. So for Alice, we already have alice@example.com, but we want to replace that email with alicenew@example.com. When I run this, I have the new email for Alice is alicenew@example.com. So always use a where clause with an update statement. Syntax again is update table name set column name equal to the new value, where the unique column name is equal to the value that already exists. All right. When we want to delete data, you can just say delete. Let's say we want to delete everything from the table. You want to use truncate statement instead of. If you want to empty the table, you can say truncate. But if you want to delete data safely, you can say delete. So if you have a delete button, so you want to say delete from the name of the table. Let's say we want to delete from users, right? And then you have to use a where clause. If not, you delete everything. So delete from users, where let's say username is equal to and the name of the user. So you can say Bob. We have a username called Bob. I don't want to delete this. So when you delete Bob, let's just try this. So you can see when Bob is deleted, even the permissions and everything will cascade automatically. So let's say let's delete from username from the users table where the username is Bob. When I run this, there's no longer Bob, only Alice we have. But when I want to select user permissions now, you will see that Bob no longer has the permission that it has before. Bob doesn't even exist on this table anymore. Okay, only user ID 1. Bob is gone because Bob was user ID 2. So you can see how that foreign key makes it cascade when you delete. In the next lesson, we are going to look at transactions, and we're going to see how we can make every operation succeed together or fail together. Thank you, and see you in the next lesson.